Welcome to the MacMillan Report. I'm Marilyn Wilkes, your host, and our guest is John Roemer, the Elizabeth S. and A. Varick Stout Professor of Political Science and Economics at Yale University. His research concerns political economy and distributive justice. Professor Roemer is a fellow of the Econometric Society, a past Guggenheim Fellow and Russell Sage Fellow, a Fellow of the American Academy of Arts and Sciences, and a corresponding Fellow of the British Academy. He has published many articles and books in economics, political philosophy, and political theory, including political competition, equality of opportunity, theories of distributive justice, and a general theory of exploitation and class. Today we talk with him about a book he has recently written in collaboration with Humberto Llavador and Joaquim Silvestre, titled Sustainability for a Warming Planet. Welcome, Professor Roemer.
Thank you.
It's nice to have you back on the show again.
Yes.
Let's start with an overview of the book. Please tell us about it.
Well, I'd like to start talking about the carbon budget.
Okay.
So people understand what
All right.
the problem is. We have emitted, since the Industrial Revolution, a lot of billions of tons of carbon into the atmosphere, which leads to concentration of carbon. We've emitted carbon dioxide and methane, which contains carbon. And as we fill the atmosphere up with more carbon, the global temperature rises. Computations by many scientists indicate that we have a remaining budget, and I'll say what that means in a second, of about 360 gigatons of carbon that can be emitted from fossil fuels in this century before we reach a global increase in temperature of 2 degrees Celsius over the pre-industrial level temperature, say 1850.
Okay.
And the various climate catastrophes that we've already seen, droughts, heat waves, rising water levels in some parts of the world, the volatility in climate, which has increased, are all a consequence of an increase in carbon, of an increase in global temperature of less than 1 degree Celsius. We've increased global temperature from 1850 as a consequence of our carbon emissions thus far by about 3/4 of a degree Celsius. So to go up to 2 degrees is already going to engender a lot more climate volatility than we've seen. Many people take 2 degrees as the upper limit of what we should, as the lower limit, the upper limit of what we should aim for.
Okay.
Other people say we could go higher without great dangers. But anyway, let's take the 2 degree limit. So we can only emit about, as I said, 360 gigatons of carbon from fossil fuels in the rest of the century if we don't want to exceed that temperature. That temperature is generally considered to be equivalent to having a global concentration of carbon in the atmosphere of about 450 parts per million. We're now at 400 parts per million.
Okay.
Now, in 2014, globally, we emitted 9.8 gigatons of carbon, a little less than 10. We don't have the numbers yet for 2015, but it's going to be about the same as that, maybe slightly less. If we kept on emitting at that rate, we would burn through our budget of 360 gigatons of carbon from fossil fuel in about 33 years.
Okay.
But this is a budget for the rest of the century. So that's the problem. The problem is, how can we globally reduce carbon emissions in order to stay within our carbon budget, which we think will engender global temperature rises of 2 degrees Celsius. And our concern in the book is to address this question not only from an economic viewpoint, but from an ethical viewpoint.
Okay.
And there are 2 large ethical issues. The question is, what's the fair way of allocating the budget that we have remaining over the present and future generations? If we think of a generation as 25 years, the next century involves about 3 or 4 generations.
Right.
And the other question is, what's the fair way of allocating the budget across regions of the world?
Mm-hmm.
We attempt to address both those questions.
Okay.
The particular theory that we put forth, that is to say, we base our ethical view on a concept of sustainability.
Mm-hmm.
Now, let me explain what we mean by sustainability.
Okay.
Sustainability is used throughout the environmental movement, and there are various different ways in which the word is employed. What's called strong sustainability means that we actually preserve physically what's on the earth for future generations.
Mm-hmm.
That is to say, the species, the forests, and so on. We don't take that notion of strong sustainability. We take a notion of weak sustainability, which is that we preserve the welfare or the standard of living. Let's call it welfare. It's more encompassing than standard of living. That we preserve the welfare of people on the world so their welfare doesn't fall. In particular, what we call pure sustainability means to find the path of resource use across regions of the world and across generations, which would guarantee the highest level of welfare that can be achieved consistent with all generations and all regions receiving that level of welfare.
Okay.
All right? Now, if we actually calculate that path of resource use, and by resource use I don't only mean carbon emissions, I mean how much investment do we decide to make in capital, how much do we want to educate people, how much do we want to commit to research and development, which will further technological change, which will reduce carbon emissions. So we look at the whole gamut of what an economy has to decide, and the path of resource use is a complete description. In a simplified way, we have a model, is a complete description of the path of resource use across generations and across regions of the world.
Okay.
Now, if we try to find the path that will guarantee the highest level of welfare, consistent with that level of welfare being sustainable indefinitely, there'd be no growth in welfare. Every generation would have the same amount of welfare, and that's not a very appealing proposition. Why? Because our own welfare is so much massively higher than the welfare of people 200 years ago. And we value the fact that our welfare is improved, and we should probably desire that the welfare continue improving.
Sure.
So we're not no growth people. We think growth is very important. Growth is important because it increases the standard of living, it increases life expectancy, it increases the extent to which people can realize themselves and their plans. And also, from a political point of view, growth is probably the politically easiest way of bringing up the standard of living of the poor, in particular the global poor.
Right.
Right? I mean, it'd be great if we could redistribute very simply income and wealth from the rich to the poor, but given that that's difficult, a simpler, less contestable way of increasing the welfare of the global poor is to have economic growth. So we think that most people would like to have growth. That is to say, they'd like to have a welfare level slightly lower than they could have on this pure sustainable path if they invest more in the future and thereby permitting economic growth to occur.
Okay.
So what we call growth sustainability is the following. Pick a growth rate that we're happy with donating to the future, say a growth rate of 1% of welfare a year. You could have said 2%, but I picked 1% for a reason.
Okay, and you'll tell us?
I will tell you
Okay.
later. The question is, if we take 1%, is it possible to design a plan of resource use so that all generations have a welfare level of at least 1% higher than the previous generation, and this goes on forever.
Okay.
Now, if we did that, we would in fact have to solve the climate problem, because increasing welfare of 1% includes the fact that people's welfare is affected by global warming. And if we break our carbon budget, it's likely that welfare for lots of people is going to decrease pretty massively. So if we could do this, since the costs to person's welfare, the disutility that the person experiences from a warming world counts, we would also be solving the carbon problem.
Okay.
So that's the other thing we do in the book. We compute, given our model, what the path of resource use is that would stay within the carbon budget that we have and increase welfare for all regions of the world and all generations at the rate of 28% per generation,
Okay.
which is equivalent to 1% per year in a 25-year generation.
Okay, that is a lot of information to take in. So you've been working on this book for a while now. How long has it been?
About a decade.
About a decade. So over the course of that decade, have you had to modify any of your assumptions, I'll call them?
Well, I think the more we've learned as we've studied the problem and worked on our model, we've had some surprises in what we've learned.
Okay, and what were they?
Well, one question that we didn't know the answer to before we started is the following. Let me explain the inter-regional problem a little bit
Okay.
to pose the question properly. Let's take the example of China and the United States. China is growing faster than the United States. Its level of welfare per capita is growing faster than ours, although our level of welfare is quite a bit higher than the Chinese level. Consumption, education, knowledge, and so on. We believe that the only possible way of allocating the carbon budget across regions of the world in the next 2 or 3 generations is going to be one which maintains the date at which China would have converged to the global north in welfare per capita, or let's say standard of living per capita. Let's say that we could compute that if we didn't have to worry about the climate problem and economic growth just continued the way it's been going for the last 50 years or so, or in China the last 30 years, that China would converge to the global north, that is to say Europe and the United States and the highly developed countries, in standard of living in 75 years. That's not a bad guess, actually. We can justify. Some people say 60, some people say 100, but 75 years is not a bad conjecture. We think that the politically feasible way of dividing the carbon budget between the global south and the global north is to preserve the dates of convergence of countries in the global south to the global north. So if China would have converged in 75 years, the allocation of carbon emissions to China and the US should be such that convergence continues to be in 75 years. Convergence may be at a somewhat lower level of welfare than it would have been if we didn't have to worry about the carbon problem, because we're going to have to all massively cut back on emissions.
Right.
But we think the date of convergence should be maintained. And we argue in the book that that's a politically necessary desideratum or condition, because imagine what would happen if a proposal were on the table which entailed that that China would catch up the United States in 100 years. Suppose the Chinese economists could compute that. They're going to say, look, we would have converged to you in 75 years under what's called business as usual. We didn't have to worry about the carbon problem. And now you're retarding our date of convergence by 25 years. Why should we accept that? And conversely, if a proposal were on the table saying that that China should converge to the global north in 50 years, the United States will say, well, you would have converged in 75 years. Why should the fact that we're all facing the same crisis mean that you converge to us sooner? So we think that it will be much easier, in particular, for these countries to convince their citizenries of the plan, which will involve some national sacrifices, increase in gasoline taxes and so on, cut back in carbon use, if the date of convergence is maintained. So what we do is we ask the question, what is the method that resources should be used? How should our economies grow? So that, first of all, China continues, or the global south more generally, continues to have dates of convergence which are unchanged from what they would have been to the global north. And secondly, stays within our carbon budget, right?
Okay.
And thirdly, no country should grow too slowly. We're a little more explicit about that. And we find that the answer to that question is that the global north, on the optimal resource path, which satisfies these criteria, can grow at about 1% a year for the next 75 years, and thereafter about 1% a year.
Okay.
Now, China similarly will have to cut back its growth rate from what it otherwise would have been, not to 1%, but to something somewhat lower than what would have been the case. But the dates of convergence will remain the same.
Okay.
So that involves, that really is stating the problem, that if we want to solve this crisis that we're in a fair way, and we think this idea of maintaining the dates of convergence, it might be not the fairest way of doing it, but we think it's the politically feasible way of doing it.
Okay.
That we're going to have to cut back our growth to about 1% a year.
Okay. But in the meantime, you had said earlier that we have until about 35 years to cut back on our carbon.
No, I didn't. I said
Oh.
if we continue emitting carbon
Okay.
at the rate that we're currently doing so, we will burn through our entire budget for the rest of the century in about 30 years.
Right. So that's
So we can't do that. We have to cut back massively in the amount of carbon that we're
right,
emitting.
right. So what's the plan for that? Do you have any kind of strategy that you put forth?
Well, I can tell you what the path will be. We define the model, our model works in 25-year generations. So
Okay.
as I said, in 2014, globally we produced about 9.8 gigatons of carbon from emissions from fossil fuels. We have to cut that back to about, for the 25 years, we started at 2010. For the 25 years from 2010 to 2035, we have to cut back to about 8.47 gigatons of carbon. For the 25 years after that, I don't remember, I have to look at my chart in here. For the 25 years after that, we have to cut back to about 3.41 gigatons. That's globally.
So that's everyone on the planet working towards these goals.
Yeah, and for the 25 years after that, we have to cut back to 1.47 gigatons of carbon.
Now, do
so
you
that's
think
a
that-
pretty massive cutback.
Exactly. Do you think that's feasible?
We make rather conservative assumptions. We don't depend upon a deus ex machina, the discovery of some magnificent technology that's going to produce energy without carbon. We simply extrapolate the rate at which technology has gotten better in terms of producing dollars of output per unit of carbon emitted. We extrapolate that rate over the next century, where we take account of the fact that in our resource use, we're going to be investing more in research and development than we have in the last period. And so that rate may increase because the more research and development we do on technology, the more we can improve the technology. So endogenizing how much research we do, which is what the model does, we think that it's feasible to do this. That's what we calculate. It is feasible. Now, as I say, it's pessimistic because we're taking the econometric estimation of how the carbon intensity of production decreases is estimated from past data. And maybe we'll have some kind of wonderful discovery which will create a technology that can produce energy without emitting carbon. Maybe for some reason, maybe we'll learn how to really harness solar energy and other kinds of non-fossil fuel energy to do this. But we don't depend on that in the book. So in that sense, it's a conservative approach.
So in working with the two other gentlemen on this book, how did you do the research?
Well, we met quite frequently, and we talked about what we were doing and what our plans were, and we assigned out different responsibilities to different people to focus on, different parts of the work, because the work involves a lot of economic theory. We had to figure out how to compute what these optimal paths were for sustainability, and that was a new economic theory because most economists have not used the concept of sustainability in studying the climate change problem. They've used something called discounted utilitarianism.
Right, right. And let's talk about that a little bit, because
So-
you do depart from what is generally, other scholars generally have thought on this topic.
Right.
So tell us about
Well,
that.
the standard approach that has been used in growth theory in economics goes back to a mathematician named Frank Ramsey, who worked in the late 1920s, a brilliant mathematician, who today he might be called a mathematical economist, who wrote down the first models modeling economic growth and how we should aim at it. And the models he used imagined or stipulated that there's one average representative household at each generation, and it has a utility function which defines what its welfare level will be as a function of its consumption. And it assumes that the utility function is the same for every generation, and then it tries to maximize the discounted sum of those utilities across generations. What does discounting mean? It means that the utility of the first generation counts for 1 unit. I mean, it's utility. But you don't add to that the utility of the second generation. You add, say, 0.98 of utility of the second generation. And the third term is 0.98 squared times the utility of the third generation. And so you geometrically discount the weight that you put on future generations, and you try to find the path of resource use that'll maximize that discounted sum.
Okay.
Now, we don't think that that's as good an approach as doing what we do, which is to find the resource path that allows utility to grow at a constant growth rate. And those are different objectives, different social objectives. In particular, the economists who use discounted utilitarianism, we think, discount the utility of future generations by far too much.
Okay.
So for instance, Bill Nordhaus, also at Yale, discounts the utility of each generation at a rate of about 2%. So the second generation's utility gets away to 0.98, and the third one 0.98 squared. Excuse me, that's not generations, that's per annum, 2% per annum.
Okay.
So the consequence of this assumption is that, or maybe 1.5% per annum, is that the utility of people living 100 years from now only counts about 13% as much as our utility.
And why is that?
Let me just,
Okay.
before explaining what the
Sure.
justification is,
Okay.
let me say why I think that's wrong. I think the only, and so in particular, we're giving very little weight to people in the future, to their welfare. And we say that's impermissible, that the utility of future people counts as much as ours. And the only justification for discounting future utility is the possibility that future generations might not exist, that there'll be some massive crisis. It could be induced by climate, could be a meteor hitting the Earth. But it is okay, it's ethically okay to discount future generations because there is a probability they won't be here, but for no other reason. Now, how do we compute what approximately the discount rate should be?
Right.
If we were doing discounted utilitarianism. As I said, Bill Nordhaus uses 1.5% or 2% a year. Other people use smaller numbers, but let me just explain what we think the correct way of computing this is. The human species has been around for, let's say, 100,000 years. That's about 4,000 generations. Let's say the probability that we made it this far was 1/2. We did make it this far. Let's just say, back of the envelope, let's say the probability is 1/2. From that, you can compute what the probability of disappearance at each generation was. You say it's a constant probability of disappearance over all these generations. What would that probability be to generate a probability of our having existed 100,000 years of 1/2? Turns out that it's 0.00017. That's the probability for each generation's being the last one.
Wow. Okay.
Now, Nordhaus is using 0.015. That's 1.5. So the true probability that should be used to discount future utilities is several orders of magnitude, 3 orders of magnitude smaller than what Bill Nordhaus is using. For those who know the Stern report, it's also 2 orders of magnitude at least smaller than what Nicholas Stern uses in the Stern report. So we think that these calculations are just not ethically cogent.
Okay. Oh.
The ones with these very large discount rates.
Right, right. Okay, so, what is your hope for the book? I mean, why did you write the book, and what would you like people to take away from it?
Well, the book is mainly written for economists. It's a technical book. We're thinking about writing a simpler version of it for more, consumption by more people without all the equations. But at the moment, this is what we have. And the main purpose is to carry out a debate within the economics profession about how we should think about future generations and apply that to the climate problem. I mean, I guess our greatest hope would be that we have some influence on how we actually solve the climate problem. In particular, that people think of there being a responsibility towards future generations and adopting the idea that maintaining the date of convergence of the global south to the global north, which will be different in different countries, should be is a very good, we think, rule of thumb for calculating what the allocation of carbon resources should be.
And do you think it's feasible?
Yes. Well, I
feasible
mean, our
plan?
paths, the whole purpose of the computation is to show what's feasible given our economies, given the laws of motion of economies, and so on. Now, let me make a comment about the level of abstraction of the book. We don't discuss issues of, let's say, should we tax carbon or should we have cap and trade? Those issues are important, but they're not as important as the question of deciding how the carbon should actually be used. I mean, what the actual allocation of carbon should be to places in the world. Before you use cap and trade, you have to know how much each region is allocated. And that's the problem we're trying to use, we're trying to solve. We think cap and trade is probably a good way of doing it. Taxes may be a good way of doing it. But in any case, we have to theoretically have a conception of what we want the allocation of carbon budget to be to different regions of the world before we can apply these techniques.
And ultimately, what do you conclude in the book?
Well, we conclude that, I mean, from a political point of view, the main, I think, problem for implementing successful global cooperation on this matter is the American Republican Party. Because the American Republican Party is not admitting that we have to do any cutbacks in carbon use at all. They're denying the existence of a link between fossil fuel consumption and carbon concentration in the atmosphere and global temperature. And really, there's no other really important institution in the world, as important as the U.S. Republican Party, which takes this position. So that's going to hold back the level of cooperation. The Paris talks, which occurred in December, last December, which were the 21st meeting of the group that has met over the last, since 1990, the international group to talk about trying to solve the problem, were much more successful than previous meetings. They really made headway, but a large part of that headway was based upon the fact that President Obama made promises about how much the U.S. would cut back in carbon production. Those promises were then met by the Chinese. The European Union had already made such promises, and about 150 countries came to these meetings making promises about what their cutbacks would be. Some of these promises are contingent on getting aid for poor. Some of the promises of poor countries are contingent upon getting a certain amount of aid from the global north to implement these changes in their technology. But at least countries came with promises.
Right.
Now, if the United States doesn't fulfill its promises, that's gonna destroy the whole agreement.
Right,
and
right.
yesterday, I think, or 2 days ago, the
Yes.
Supreme Court
Dealt a blow.
dealt a blow to the efforts of some states have taken the view that they're not going to implement the EPA regulations that have come down through the Obama administration for cutting back emissions mainly from use of coal. And the Supreme Court had to decide whether they were allowed to do this, and they decided 2 days ago that they weren't, they're not going to make a final decision on it yet. And it'll probably be, so they're going to permit these states that are non-cooperators to not cooperate, at least probably for the next year. And that's going to really throw a wrench in throw a spanner, as the British say, in the possibility of getting this global cooperation off the ground.
Scary times in terms of climate these
Yes.
days. So hopefully your book will make a difference and help people on the right path moving forward. Thank you for being here today
Thank
with
you,
us
Marilyn.
and sharing some of your work. For more information about Professor Roemer and his research, please visit our website at macmillanreport.yale.edu. Be sure to join us again for another episode of the MacMillan Report, made possible through funding from the Whitney and Betty MacMillan Center for International and Area Studies at Yale.